When we talk about a linear system of equations, we're talking about two equations with the same solution, two variables. We're going to look at three variables in a little bit. So let's say we had a graph. And the first equation has some graph like this. Call that line 1. The second, we'll call this line 2. So here, these graphs intersect at exactly one point, some point xy. We say that this system is consistent and the equations are independent. We also have the possibility that our two lines are parallel. In this case, we would say the system is inconsistent and independent. Don't worry, I'm going to go back through these terms and help us make sense of them in just a minute. We also have the case where line 1 and line 2 are exactly the same line. Maybe we have two different equations that work out to the same line. We call this consistent and dependent. So, consistent, inconsistent, dependent, independent, what do we mean by this? Well, consistency, whether it's consistent or inconsistent, that is whether there is a solution or not. So this first example where the graphs intersect at one point, there is a single solution. There is a solution though, so it is consistent. Since the lines are different lines, they're independent. Different lines are going to be independent. The same line would be dependent. So come down here, the parallel line example. If two lines are parallel, they never intersect. If they don't intersect, there's no solution. If there's no solution, then it is inconsistent. They are still different lines though, so the lines are independent of each other. But then where we have the same line, well, all points on line 1 are also all points on line 2. So there are infinitely many solutions. And apologies if there should be an E in there. I'm not a spelling guy. I'm a math guy. I do know you could also just say infinite number of solutions. I know there's an E on that. I don't fall into that trap. But since there is at least one solution, that makes it consistent. But since the lines are the same line, they are dependent. The equations of the lines are dependent on each other. They are the same line. So we're going to come back to these vocab words. We're going to use them: consistent, inconsistent, dependent, independent, throughout this lesson. Keep that within reach. Now, graphically is no way to solve every equation. If you have a graphing calculator, it's a nice quick way. But for the purposes of our exploration of systems of linear equations, we're going to deal with the substitution method and the elimination method. So looking at example 1, we see something that we could use the substitution method on. We have the system 3x plus 2y equals 11, and negative x plus y equals 3. If we thought about this graphically, if we graphed this line and we graphed this line, wherever they intersect would be the solution for x and y. Sometimes you'll see a system of equations with a left brace, just showing that these are together. If we have two unknowns, we need to have two equations. If it was x, y, and z, we would have needed 3 equations to be able to solve. The solution we find is going to work in both. So it's not enough to find an x and y so that negative x plus y is 3. We're also finding that same x and y so that also 3x plus 2y is 11. This is called a simultaneous solution. So substitution is exactly what it sounds like. We're going to take something and substitute it somewhere else. We either want to get x equals something or y equals something. This is a good one for substitution because here we have an equation where the x and the y are by themselves. It would be really easy to solve for one. In fact, here's our positive y. If negative x plus y equals 3, then y equals 3 plus x. We're going to take that expression for y and plug it in the other equation. So instead of 3x plus 2y equals 11, for y, we're going to use that expression 3 plus x. So now 3x plus 6 plus 2x equals 11, which means 5x plus 6 equals 11. 5x equals 5. So we get x equals 1. We're not done though, because we need x and y. We have x equals 1. We don't know what y is yet. But wait, y is 3 plus x. X is 1. So y equals 3 plus 1, which means y equals 4. So our solution is x equals 1, y equals 4. We could also express that as the ordered pair 1, 4. Remember, if you do an ordered pair, order matters, x then y. So that's the substitution method. We also have the elimination method. Some rules we have for elimination. We can interchange any two equations. We can just switch them around. We can multiply or divide any equation by some non-zero real number, if it's helpful. And we can replace any equation of the system by the sum of that equation and a multiple of another equation in the system. So that's the words. It's not really as complicated as it sounds. In example 2, we have the system 3x minus 4y equals 1 and 2x plus 3y equals 12. The elimination method is also called the multiplication addition method in some places. And that's because literally to do this, you're going to multiply and add in order to, wait for it, eliminate one of the variables. So if we added this down right now, we would get 5x minus y equals 13. We want to find two equations that we can add down, and one of them, one of the variables would go away. So let's say here with our y's, one of them's negative, one of them's positive. We're already off to a good start. What's the least common multiple of 4 and 3? 12. Well, what do we need to multiply 4 by to get 12? 3. What do we have to multiply 3 by to get 12? 4. Since one was negative and one was positive already, we're going to keep it positive 3, positive 4. We should end up with a negative 12y and a positive 12y, which will cancel each other out. When we multiply through, our new two equations are 9x minus 12y equals 3, and 8x plus 12y equals 12 times 4 is 48. Now, let's add down. 9x plus 8x is 17x. Negative 12y plus 12y cancels. 3 plus 48 is 51. Divide both sides by 17. And we get x equals 3. We're going to take that x equals 3, plug it into either of the two original equations. And notice either way, whether we're doing 3x minus 4y equals 1 or 2x plus 3y equals 12, when we plug in 3 for x. Nine minus 4y equals 1, which means negative 4y equals negative 8, which means y equals positive 2. Or if you did the other equation, 6 plus 3y equals 12, so 3y equals 6, so y equals 2. Either way, you're going to get y equals 2. Pair that with your x equals 3. Our answer is 3, 2. You could always check, put them x and y into both original equations. As long as both equations check out, you know you're right. Now, let's look at some special systems. Example 3 says solving an inconsistent system. What did inconsistent mean? Inconsistent meant that there is no solution. If we graphed it, it would be parallel lines that never intersect. We have 3x minus 2y equals 4, and negative 6x plus 4y equals 7. That is our system. Here, we can choose to eliminate the x's or the y's. Positive, negative, negative, positive, so we'll choose a positive number either way. The signs will already be different. Notice, if you multiply this first one by 2, it gives us 6x plus 4y equals 8. And if we leave the second one alone, or sorry, minus 4y here. It should have been minus 4y on the top. If we leave the second one alone and add down, the x's cancel, the y's cancel, we get 0 equals 15, which is not true. So we get no solution. This is an inconsistent system because there is no solution. But we did not get the same line. They are not the same line. That's going to be the other type of special system. An example 4, solving a system with infinitely many solutions. (8x minus 2y equals negative 4, and negative 4x plus y equals 2. Positive, negative, negative, positive. So the signs will already be different from one equation to the other. We don't have to worry about picking a positive number and a negative number. Let's multiply the second equation by 2. That'll give us an 8 there, a 2 there, which will enable us to get rid of either variable. So this is going to be a special system because of the fact that both variables go away. But you'll see now the difference from the last one. Negative 8x plus 2y equals positive 4. Not only do we get 0 on the left, we get 0 on the right, which is a true statement. We have an identity. If it's always true, there are infinite, yeah, I think there's an E in there. Infinitely, unless there's not, many solutions. Why don't I just say all real numbers? Well, in this case, all real numbers would not be an accurate description. You can't put any number in for x and any number in for y and have it be a solution. There's infinitely many solutions of the form 8x minus 2y equals negative 4. You can pick a value for x and solve for y, and that will be a solution to the system. There are infinitely many solutions. So how do we describe infinitely many solutions? Well, remember that was where they are the same line. Notice only things on that line will be a solution, not something out there or something over here. Since there is an answer, it is consistent. Since it's the same line, it is dependent. As opposed to this one, which would graph as parallel lines, inconsistent and independent. Here we get a true statement, and that one we got a false statement. In both of them, though, both variables went away. We can see here this is the same line because one of those rules for the elimination method was multiply or divide any equation of the system by a non-zero real number. So when we see this, we could have divided both sides of this by 2, by negative 2, which would give us exactly negative 4x plus y equals 2. We could have seen right there, they are the same equation. You can't do that here. There's no way of making the left side the same and having the right side be the same.
Okay, so we're going to go through and review systems one more time. And then I'm going to show you a word problem where we can actually use the concept of a system of equations to solve the word problem. So first, let's take the system y equals negative 2x minus 2 and 5x plus 5y equals 0. And let's solve this using the method of substitution. We would use substitution because it's very clear here that the variable y can be represented by negative 2x minus 2. So we're going to take that and plug it in for y in the second equation. So 5x plus 5y becomes 5x plus 5 negative 2x minus 2 equals 0. Distribute 5x minus 10x minus 10 equals 0. 5x minus 10x is negative 5x minus 10 equals 0. I need more room. I'm going to move it over here. Negative 5x minus 10 equals 0. Add 10 to both sides. Negative 5x equals 10. Divide both sides by negative 5. X equals negative 2. We're not done. We have to take our x equals negative 2 and solve for y. Y equals negative 2x minus 2. That means y equals negative 2 times negative 2 minus 2. Y equals negative 2 times negative 2 is positive 4 minus 2. Y equals 2. So our answer is going to be the ordered pair where x is negative 2 and y is 2. Another system of equations. This time our first equation is 4x minus 3y equals 10. 3x plus 4y equals negative 5 will be the second equation. Let's solve this one using the addition method. Well, we see this second term here. One of them's minus, one of them's plus. If only they were the same number, they would cancel away. Like if it was 3 and 3 and 4 and 4, we can't make that happen. What we can do is multiply that 3 up into a 12 and multiply that 4 up into a 12. We can accomplish that by multiplying the first equation times 4 and the second equation times 3. First equation becomes 16x minus 12y equals 40. Second equation becomes 9x plus 12y equals negative 15. And when we add them together, the y's are now gone. Minus 12y plus 12y. Cancel away. 16 plus 9 is 25. So 25x equals 40 minus 15. That's positive 25. We have 25x equals 25. Divide both sides by 25. We get x equals 1. But we're not done. We need to get y as well. So we pick one of the two equations that we started with. I'll just take 4x minus 3y equals 10 and x equals 1. 4 times 1 minus 3y equals 10. We're going to solve for y. 4 minus 3y equals 10. Subtract 4 from both sides. Minus 3y equals positive 6. And if we divide both sides by negative 3, we get y equals negative 2. So our answer is the ordered pair where x is 1 and y is negative 2. Camille and Sasha each make an ice cream sundae. Camille gets 1 scoop of cherry ice cream and 3 scoops of mint chocolate chunk ice cream for a total of 63 grams of fat. Sasha has 3 scoops of cherry ice cream and 2 scoops of mint chocolate chunk ice cream for a total of 84 grams of fat. How many grams of fat does 1 scoop of each type of ice cream have? With this information, we are able to answer that question. And we're able to answer it by first setting up a system of equations. Let's let C stand for cherry, and let's let M stand for mint chocolate chunk. And C and M are going to stand for the grams of fat in each of those. C for cherry, M for mint chocolate chunk. Let's read this again, starting with Camille. Let's make an equation for Camille. Camille gets 1 scoop of cherry and 3 scoops of mint chocolate chunk for a total of 63 grams of fat. So see what I did there? 1 cherry plus 3 mint has 63. Now let's do the same with Sasha. Sasha has 3 scoops of cherry and 2 scoops of mint for a total of 84. Now, if we solve for C and M, we'll get the grams of fat in 1 scoop of cherry and 1 scoop of mint chocolate chunk. Because this C is by itself, I'm going to go ahead and change C plus 3M equals 63 into C equals 63 minus 3M. And I'm going to take that C and I'm going to plug it into the second one. So I'm going to use substitution, but you could also do addition. You could multiply the top one by -3. Then you'd have a -3C and a 3C. Things would cancel. You can go from there. You'll get the same answer no matter how you solve it. You just have to be able to solve it. So if C is 63 minus 3M, then we have 3 times 63 minus 3M plus 2M equals 84. 3C plus 2M is 84. C is 63 minus 3M. And we got that by solving the first one for C. 3 times 63, that's 189 minus 9M plus 2M equals 84. 189 -9 plus 2 is -7M equals 84. Subtract 189 from both sides. That's going to give me -7M equals -105. If I divide both sides by -7, so -7M equals -105. Whoops. Divide both sides by -7. I get M is positive 15. What does that mean? That means that the mint chocolate chunk has 15 grams of fat per serving. Plug that in here. C equals 63 minus 3M. C equals 63 minus 3 times 15. C equals 63 minus 45. C equals 18. So this information the cherry has 18 grams of fat per serving. The mint chocolate chunk has 15 grams of fat per serving.